Okay, now that we've worked on trying to determine the charges that ions have, we're going to next look at how to put ions together so that we can make a compound out of them. So if you remember back to electrostatics from grade 9, when we had things that were positive and another thing that was negative, they attracted one another. And we did this with various rods and pith balls and pieces of paper, but there's an attraction between a positive and a negative object. So we can use that same attraction to build compounds. One of the positive part will be the cation, the ion that has the positive charge, and the negative part will be the anion, the ion that has the negative charge. Right? So during a chemical reaction, we can put two atoms together. They can lose and gain electrons. One of them will lose and one of them will gain. And the result is a negative ion, a positive ion, and then they stick together to form a new compound. So you can see this happen if you go online. I'll just launch this video quickly and we'll watch a little bit of it, and then you can go back and see the rest if you're interested.
So this is my little setup to make some table salt, also known as sodium chloride. So just from the name sodium chloride, you can pretty easily see that it has two major components, sodium and chlorine. On their own, both elements sodium and chlorine are pretty reactive and dangerous. However, interestingly enough, when they are combined, they form a nice edible salt. This is an interesting demonstration that shows how drastically different the properties of a compound can be compared to its components.
So let's take a look at what's happening in that reaction you just watched. If we use Bohr-Rutherford diagrams, we had sodium atoms were put in that flask. They have 11 protons, 3 orbits, with just 1 electron in the outside orbit. So sodium is in group 1 and has 1 electron. We also put in some chlorine. Chlorine is element number 17, so it has 17 electrons, and its last orbit has 7 electrons. Just like we said, it's in group 17, so it has 7 outside electrons. Now, in our previous work, we looked at how things would react, and we realized that if it can, an atom wants to empty its last shell, last orbit. So sodium, being a metal, wants to lose 1 electron, and when it does, chlorine, being a non-metal, will take that 1 electron because that'll let it fill its outermost shell. And so sodium and chlorine react very well together. Sodium has 1 to lose, and chlorine has 1 to gain. So when we're done, we have a sodium atom that has a charge of 1 plus, because sodium lost 1 electron. And we have a chlorine atom that has a charge of negative. And so those two things will stick together and they will form a compound called NaCl, or sodium chloride. Okay? Now we can look at Lewis diagrams, and I'd like to do that going forward to see what happens because they're just a little easier to draw. We have to do a little more thinking with this just to get it set up. So sodium, what we do is we write down its symbol, Na, and sodium would have 1 electron because it's in group 1. Chlorine, we write down Cl, and it would have 7 electrons because it's in group 17, and the last number in the group number tells you how many electrons to put on the outside. So that would be the Lewis diagram showing sodium and chlorine. And again, you can see we can empty sodium by losing this electron, fill the last orbit of chlorine by gaining that 1 electron, and then again, once again, making that compound, the Na plus, Cl minus, and that gets written out as the compound sodium chloride. Okay, so a couple of different ways of predicting and looking at how a compound is made. Now, when you go to predict formulas, this is one way of doing it. We're going to show you a short form in a little bit, maybe in the next video. But for now, we're going to use these ways of predicting formulas. So let's just do one more example together. if we wanted to predict the formula between sodium and oxygen, the very first thing we would do is determine how many outer electrons are around the atoms. Well, we do that by looking at our periodic table. And when we look at our periodic table, we can see that sodium is in group 1 and oxygen is in group 16. So that tells me how many electrons are in the outer orbits of those atoms. Sodium, being in group 1, gets 1 electron. And oxygen, being in group 16, gets 6 electrons. 1, 2, 3, 4, 5, 6. And so it doesn't have a full 8. Sodium only has 1, and metals like to lose. Non-metals like oxygen like to gain. So this one would actually move over to here, and that would empty out sodium, making it an ion. But the problem is we haven't finished filling up oxygen. So what we can do is there are millions upon millions of atoms in any sample that we work with in the lab. So we can take another sodium atom, and then we can take that electron and give it to oxygen as well. Now oxygen is filled up its outer valence shell. Sodium has emptied its valence shells, and so we can write down what the result is. So this time, instead of just writing Na, we write Na, and we use 2 of them. So we put a little 2 down here, and then we write the oxygen. We go O, but we only use 1 of them. And so it's Na2O. And that's our formula for a molecule, for a compound called sodium oxide. Okay? And again, it's the same as we were doing before. There's 2 positive sodium ions that are being attracted to 1 oxygen ion that has a -2 charge. So these 2 positives are attracted to this -2, and they hold together to make the compound sodium oxide. So just to review that again, I determined how many outer electrons there were. Then I determined what kind of ion the atom would form. Well, sodium would lose electrons, oxygen would gain them. And then we combine the ions so that the compound has the same number of positive and negative charges. Well, that took 2 sodiums to get 2 positives to match up to the 2 negatives that were on the oxygen. And that's how you predict a formula. Okay, so we'll do, I think we'll leave the video there. Or maybe let's just do this one more example, and then we'll stop for this video. So we've got sulfur and lithium. So we're going to do the same things. Write down the atoms, what they look like. So sulfur and lithium. So we need to go look those up on our periodic table. So I'll go back to my browser here. Sulfur is here in group 16, and lithium is in group 1. So that means that sulfur, because it's in group 16, has 1, 2, 3, 4, 5, 6 electrons. And lithium, because it's in group 1, has 1 electron. This is looking very similar to the last one we did. Lithium is a metal, so it's going to lose electrons, and sulfur will gain electrons to fill up its last orbit. But again, lithium is now empty, but sulfur is not full yet. So that means we need another lithium atom and its electron, and we're going to put it into the sulfur. Okay? And then we can write the results. Well, we used 2 lithiums, each with a positive, so we write Li2, and then 1 sulfur, S. And if we check again, that makes sense. We have 2 lithiums, each with a positive, and they're stuck to an S that has 2 negatives. So all together, that adds up to be 2 positives and 2 negatives. That makes a good compound. And this compound is called lithium sulfide. Okay, so that'll get you started on some of the stuff on the worksheet. And we'll come back and do another video where we look at something called the crisscross method. And once you've got good at drawing the diagrams we were just looking at, we can use the crisscross method to make our predictions much, much faster. Okay, but first, if you go and practice this method of figuring out a compound, and then we'll watch another video after that. Thanks.